All right, should be on the linear program side where it says it there at the top. I'd like to invite you all into the t-shirt. So how many shirts do we make? We just start making them and hope people buy them, right? Or would you rather know exactly how many? Exactly. Do you want to go in the hole or do you want to make money? Make money. Some of us want to go in the hole. Some of us probably will. But most of us would like to make money. So we need to know how many shirts to make, or whatever it is that you're making in life when you own your own business. You want to know how to do this. So the goal right there, maximizing profit. That's what we want to do. It says your factory produces short sleeve and long sleeve shirts. A short sleeve shirt requires 30 minutes of labor. A long sleeve shirt requires 45 minutes of labor. And you only have 240 hours of labor available each day. So that right there puts a constraint on you. You can't make an unlimited amount of shirts in one day, right? Remember, you have to write the inequality, so be thinking about that as you're reading through these problems. What are the constraints? Where are my limits? The maximum number of shirts that can be packaged in a day is 400. So no more than 400 shirts should be produced. But the profits on a short sleeve shirt and a long sleeve shirt are 11 and 16 respectively. Find the maximum possible daily profit.
Would these students please report to room 11 for the PSAT test? Chris Window, Caitlin Perkins, Caitlin McLean, Jake Marshall, Tim Hanley, and Angela Fisher. Please report to room 11 for the PSAT. Again, Chris Window, Caitlin Perkins, Caitlin McLean, Jake Marshall, Tim Hanley, and Angela Fisher. Thank you.
So you have this whole area to do all of your work. You will write all your objectives, you will draw your graph, you will solve and find your solution, all on the same side of the page. You have plenty of room right there. So we'll split this up into steps for you. Step 1, you will write an objective. That objective what are we maximizing? Or minimizing, but in this case we want to maximize. What is it that we would like to maximize? Profit. So first we have to label some variables. What two things are we talking about in profit that we are making? Short sleeve and long sleeve. So that's the question, is how many of each one? So we're going to let X represent the number of short sleeve. So Y will be the number of long sleeve. So to find the profit from a long sleeve shirt, how much do we get for each long sleeve shirt? $16. How much for every short sleeve? So our profit, what we are trying to maximize, we will get $11 per short sleeve, 11x, plus $16 for every long sleeve, 16 times Y. However many we sell, we get $16 for each one. So that is step 1. Write your objective. This is your objective. This is what you want to maximize, that profit statement. You want that to be as high as possible. Step 2, you write your constraints. So again, last time in the bookwork you were given all the constraints. Okay, you have to write it based on this information. So what's one thing, as I told you as we were reading through there, that we are limited on? Time. The amount of labor in a day. What can it not be more than? 240. So an inequality would be which one? Less than that. So less than or equal to 240. We know that part. Our labor hours has to be less than that. So how many labor hours for a short sleeve? Or minutes, I guess.
Can you just put 0.5?
Yeah, because we have to, this is in hours, remember? In the 30 minutes. We'll probably do it all in minutes. Probably convert it.
Wouldn't it be just as easy to do it?
Yeah, you can do it either way, but I'm going to do it in minutes.
Oh, that's fine. I just
Yeah, but they have to be the same, either minutes or hours. So the 30 minutes for one short sleeve. So 30x plus how many minutes for a long sleeve? And right over here to the side, we have to convert the hours, 240 hours, into minutes per day. So what would that give us? 14,400. So the minutes for a short sleeve plus the minutes for a long sleeve cannot be more than, it has to be less than or equal to 14,400 minutes per day. What's another limit that we have? We can't package more than 400 in a day. So again, less than or equal to 400 packaged. And what are we talking about there? What can't be more than 400? The number of both. So the number of short sleeve plus the number of long sleeve. So there's two constraints. What else do you think would be a constraint as far as producing something? What can you not do? Unless you're in like Twilight Zone or something. If you're making a product, can you make negative? No. So you either make 0 or more, right? So the number of long sleeve or short sleeve shirts that you produce would have to be what? Greater than or equal to 0. You don't have to produce any shirts, right? You can just sit there at your factory all day and whatever, do nothing. But you don't have to produce anything. So it has to be greater than or equal to 0. And the same with the long sleeve shirts. Why? It has to be greater than or equal to 0. Which makes sense. You can't produce a negative number. So there are our 4 constraints. It will be pretty difficult to graph 14,000, or if you put them in decimals, it could be pretty difficult to graph the decimals as well. So, can we simplify these 3 numbers at all? Everything that goes into all 3. At least 5, but more than 5 goes in there. 15. So we can divide all of these by 15 to simplify this one a little bit. Which would give us 2x plus 3y is less than or equal to 960. 960 is still not that easy to graph, but it's easier than 14,000. So that's step 2, write those constraints. Step 3 is graph them, and you will need to label them or use colored pencils, either way. Now, you only need quadrant 1, because what did we just say? You can't make negative. So you don't need to have any of the other 3 quadrants. You just need quadrant 1. So on your paper, somewhere maybe down here toward the bottom, just make your quadrant 1. This is all you need down here somewhere where you can sketch your lines. And I should say, too, now that you've got those constraints written, it is no different than the footwork was. Okay? So once you get that done, it's just like last time. But we'll go ahead and walk through it together. The other thing that's going to be different, and it will be different in application problems, is your answers won't come out to nice, neat answers like the bookwork did, because this is a real-life problem. So you'll probably need to change your window. So hit your window key, because we don't need anything negative anymore. So for your X minimum, so go down to your X minimum, that's 0. We don't need anything below 0 for the X. And let's make the max 400. And same with the Y minimum. That's 0, and the Y max is 400. Now hit your Y equals. Of course, you'll need to put out anything from the last period. And before we type in the ones that aren't just X or Y, these two right here, the X and the Y greater than 0, that's just saying you can't go below this line. So we're shading above that. And you can't go to the left of this line. So we're shading to the right of that. That's all those two say. It has to be up here somewhere. Question? 3. So we've done those first two, or those bottom two right there, the X equals and the Y equals. We've already got those graphed on there. So all we need to do is solve these two top ones, figure out where they're at. So let's solve that top one for Y. What would we need to do there first? This one right here. What do we need to do first? So we subtract the 2x. So we have 3y less than or equal to negative 2x plus 960. Then what? Divide by 3. So we have y is less than or equal to negative 2/3 x plus 330, 320. And to solve this one for y, we just need to subtract the x. So y is less than or equal to negative x plus 400. So these two right here are the ones you need to type in your calculator. Go ahead and do that now. Remember, again, to use your negative key, not a minus key.